Hello one and all, welcome to the Math Magic Show. And this one, let's take a look at simplifying this expression that involves high powers of I. What I'm going to do is always try to look for I squared. Why would I do that? Because I squared, as you know, is, for example, -1. That's easy. So, what have I done here? I took the 32 and I've rewritten it as 2 times 16, because that is 32. And now I've revealed a little I squared. And also, beyond that, I've rewritten the I to the 21st as I to the 20th times I. Why would I do that? It's not obvious necessarily. It's because now, as the next step, take a look. I can do the following. I can rewrite I squared as -1, and I can rewrite the I to the 20th as I squared to the 10th, because the 2 times the 10 would give you the 20, see? But that I squared, again, itself could be replaced with -1. So when I do that, it's going to simplify down to this level right here. So I have the -1 here to the 16th. Well, it's a positive or negative number raised to an even power becomes a positive number. So that's why over here I have 3 times 1, and then where it says I squared at this step above there, that becomes just -1 to the 10th. So I'm making good progress here pretty quickly. And why would I do that again? Because now -1 to the 10th will again become +1. So let's look at the next move. It's going to look like this. I'm going to have 3 times 1 minus just 1. Let's be careful with the signs here. Remember the following, that this minus is from in front of the parentheses. So when I raise the -1 to the 10th, that kills off the negative with the 1 within the parentheses, but it leaves that negative untouched. Keep that in mind. And I multiply that by the I that's left over. And in the bottom, I'm not doing anything. I still have I minus 1. Let's go on to the next step. So let's clean this up a little bit. It's going to look like the following. 3 times 1 is 3. The -1 times I, normally we just write, of course, as just I. In the bottom, I still have I minus 1. Now, I've reduced a pretty complex-looking expression to something that involves not the division of two complex numbers, and both are relatively simple. Let's continue here. So what I'm going to do, then, not that this step is 100% necessary, but just perhaps to make it look a bit more familiar, I'm going to rewrite the bottom as -1 plus I instead of I minus 1. And now what I'm going to do, of course, is figure out how to multiply by a form of the number 1. Remember, in math, we're allowed to multiply by a form of the number 1. The goal is to make the expression look different, but not change the underlying value. Keep that in mind. That's why ever and only when you do multiply, it should be by a form of the number 1 when you're changing or you're manipulating expressions. So when I do that, here it's going to look like this. I'm taking the -1 plus I and I'm multiplying by a form of the number 1. That form happens to be -1 minus 1 over -1 minus 1, because -1 minus 1 is the complex conjugate of -1 plus I. The only thing I would observe here is when you multiply, you got to make sure that only one of the signs is changed. What I mean by that is the following, that do not change where it says -1, that's still -1. But make sure that the plus I becomes minus I. That's how you form the complex conjugate. You change the sign applied to the I. And we do that because now what we have in the bottom essentially is a product of a difference of squares, and that will make what the I disappear. And it will give us just a nice real number, like 2 or 3, whatever it happens to be. Okay, next move. Let's FOIL things out. So as a result of that operation, I'll have the following. I have 3 times -1, which is -3. That 3 times the negative I, that's going to give me -3i. Negative I times -1 is going to give me positive I. And then negative I times negative I will give me positive I squared. And in the bottom, I'm applying the difference of squares pattern. Keep that in mind. So in other words, that becomes -1, that quantity squared, minus I squared. Let's continue with the process. The next stage is going to look like this. On the bottom, the -3 stays, doesn't change, but -3i plus I will give you -2i, and of course the quantity I squared right here, that will be replaced with -1 in that position. And at the bottom we have -1 squared, which is 1, and then we have the negative here, I squared, so the I squared will be replaced with -1. So you have 1 minus -1 for that reason. Let's go on to the next step and simplify. So in the top, I will now have -4 minus 2i. And the reason is that down below, I have -3 minus 1. That's -4. The -2i stays. On the bottom it says 1 minus negative 1. That's going to give you a positive 2 as the new denominator. Now when I look through this expression, I got to observe something. So I see the following, that negative 4 minus 2i, there's a common factor of 2 that can be pulled from each term. So that's going to look like this when I do it. The negative 2 goes outside, and what's left within the parentheses is the following, 2 plus i. And the reason is the following, that negative 2 times 2 would give back to negative 4, and then negative 2 times I would give back to negative 2i, you see? So when you factor a negative, just change the signs inside the parentheses, and now you can very likely guess what will happen next. But when I look at this expression, I see that negative 2 and positive 2 can be cancelled off. And when I do that, lastly, it will give me the following. Negative 2 divided by 2 will give a value of negative 1. That's there, negative 1. And the quantity 2 plus I, that stays exactly as written there above my head. So, we began with a pretty complex looking expression, and we managed to break it down to a relatively simple looking one. That is it for me. Thank you so much for watching. Please give a like and subscribe. I'll see you in another video.